This is a quick PowerPoint to go through how to integrate sine squared, cos squared and tan squared. And in this PowerPoint, we're going to need to use the double angle formulae that you learned in the trigonometry booklet. So for a quick starter, press pause now, see if you can remember and write down the double angle formulae. There are 3 different versions for the cos double angle formulae. So press pause now, see if you can write those down or find them in your notes. I'm going to reveal the answers now, so if you haven't written them down yet, stop me before you see the answers. Here they are. These are the answers for the double angle formula. I've written them here in terms of A instead of X, but it doesn't make much difference. Sine of 2A is 2 sine A cos A. So sine of 2x, you've probably written 2 sine x cos x. For the cos of 2A formula, there's 3 different versions. Cos squared A minus sine squared A, 1 minus 2 sine squared A, or 2 cos squared A minus 1. Which one to use? Well, it depends on the question. Sometimes the top one comes in handy, sometimes these 2 come in handy. Depends on the question. The last one then, tan of 2A, is 2 tan of A over 1 minus tan squared of A. Now we're going to be using these to help us to integrate sine squared and cos squared, and in particular we're going to use these 2 versions of the cos 2A double angle formulas. So we've just noted in our start that cos of 2x can be written as 1 minus 2 sine squared x. If we rearrange that to get sine squared on its own, we'll end up with something that will be easy to integrate. So for example, we could take the minus 2 sine squared to the other side, write it as a positive, and we could bring the cos of 2x over to the right hand side. So sine squared x is 1 minus cos of 2x all over 2. So if you needed to integrate sine squared, you could integrate this instead, which is much easier to integrate. So we'll do that on the next slide. Let's do the same thing now for the other version of cos 2x. So cos 2x can also be written like this, 2 cos squared x minus 1. So I'm going to rearrange it. Cos of 2x plus 1 equals 2 cos squared x. So cos of 2x plus 1 over 2 equals cos squared x. So on the next slide, I'm going to use these 2 results. So on the previous slide, we showed that sine squared x is the same as 1 minus cos of 2x over 2. We did that using the double angle formulae. Then to integrate this, I could take the constant a half outside, because all of the top is multiplied with a half. And then we end up with something that's very easy to integrate. When we integrate 1 with respect to x, it becomes 1x. And when we integrate minus cos, we get minus sine. So minus cos of 2x becomes minus sine of 2x. And remember that we divide by the differential of the bracket, which is 2. So as you can see, integrating sine squared of x is very easy to do if you use the double angle formulae, which you definitely need to do, and then we integrate as normal. So when we did the double angle formulae earlier on, we proved that cos squared is the same as 1 plus cos of 2x over 2. And by writing it that way, we can now integrate it. Again, I'm going to take the half constant outside, so that I just need to integrate 1 plus cos of 2x. If I integrate 1, it becomes 1x. Don't need to write the 1 in. And then if we integrate cos, it becomes sine. So this one becomes sine of 2x divided by 2, because we divide by the differential of the bracket. Now tan squared is a little bit different to sine squared and cos squared, because the easiest way of doing this one is to not use double angle formulae. The best way to do this one is to use a trig identity that you learned in the trig chapter this year. which involves tan squared, and that identity is 1 plus tan squared equals sec squared, or if I rearrange that, tan squared x equals sec squared of x, take away 1. So I can replace this integral of tan squared with sec squared of x minus 1. And then, even though that looks like we've made it even worse, we have actually changed it into an integral that's very easy to work out. Do we know something that differentiates into sec squared? The answer to that is yes. We know that if you differentiate tan, you get sec squared. So therefore, if you integrate sec squared of x, you get tan of x. And of course, minus 1 just becomes minus 1x. So that's the quickest and easiest way of integrating tan squared. Here's an example going back to a question with cos squared. Remember earlier on we found that cos squared x was the same as cos of 2x plus 1 over 2. We can apply that to a question like this one. Now the first thing I would do on this one is take that 6 outside, and then the cos squared of x over 2 we can replace using this formula. But as you can see on this one, we haven't got cos squared of x. We've got cos squared of x over 2. So we can still use this formula, but where that x is, we just need to make sure we write x over 2. So it's going to look like this. Cos of 2x over 2 plus 1 all over 2. And then, of course, 2 lots of x over 2 is really just x. Now I could take that half outside and make the integral look a little bit simpler. Then I could say, of course, 6 over 2 is the same as 3. When I integrate cos x, I get sin x. And when I integrate plus 1, I get plus 1x. So even though the original question had cos squared of x over 2, I was still able to use the formula from cos squared of x, but just instead of writing x's, I wrote x over 2's. When I multiplied the x over 2 by 2, it left me just with an x, which made it even easier to integrate. So I have one more example now to show you in this PowerPoint. So this one we're integrating 2 sine 3x cos of 3x. This looks quite difficult at first glance because it looks like a product. We haven't got a product rule for integration. It's easy to use. So this is the sort of question which, if you know your double angle formulae really well, this one will jump out at you and you'll spot straight away that this is in fact a double angle formulae question. The double angle formulae for sine of 2 times something, let's call it A for a moment, is that it's 2 sine A cos A. That's a double angle formulae that we wrote down earlier. Now if we look at this question, I can see that it's 2 sine A cos A, but the A's are just 3x's. So if I write 2 sine of 3x cos of 3x, so I'm changing the A's to 3x's, that means that on the left hand side I'll have 2 times 3x, in other words sine of 6x. So this is the same as the integral of sine of 6x, which of course is very easy to work out. When we integrate sine, we get minus cos, so minus cos of 6x. We divide by the differential of 6x, and then we put our plus c. So my advice is to know your double angle formulae really well, try and memorise them. The more you see them, the more they'll stick in your mind, and then you might spot that sort of trick in this sort of question.